Welcome, everyone. Just to remind you, there will be a Q&A session at the end, and if you have questions, please come down here at the front so I can take your questions, and enjoy the talk.
Thank you, and yeah, also welcome from my side. I'm Julia Wagemann. I'm an independent consultant, and since 2019, together with MIO, which is a SME based in Italy, I support EUMETSAT, which is another intergovernmental organization in Europe, with developing and running training events for Copernicus data. And so I give the talk today on behalf of my colleague Federico Firli, who unfortunately couldn't come. But so I start now because you get from the previous speaker a more detailed introduction on some capabilities from one specific Copernicus service. And now I just zoom out again to give you a bit of a wider angle of Copernicus in Europe. So Copernicus is the European Union's flagship program for Earth observation data. So it provides a lot of information about anything related to Earth, land, oceans, atmosphere, and it supports in overall and in general to better understand climate change, to monitor and better respond to emergency crises, and to also safeguard civil security on an overall level. But the most important thing, Copernicus is a data program, and it is a lot of petabytes available on a full, free, and open data policy. Copernicus has three parts. So there is a space component, a services component. So this under services component is, for example, the climate and atmosphere monitoring services from ECMWF, and there is an in situ component. And I will focus mainly on the two components for space and services. So the space component, it's about bringing satellites into the orbit, and since when Copernicus started in 2014, there have already been 6 satellite missions launched. They are called the Sentinels, and they monitor anything related to specific thematic application areas. And we are now in 2023. There is until 2027 many more missions planned. So there will be more data, more satellites, and more information that is available, or that will be available. The services component, so the previous speaker introduced the climate change and the atmosphere monitoring service, but there's also other services such as marine monitoring, land monitoring, security, or emergency management. And important is that these services provide thematic applications and examples on how these data can be used for specific application examples. So because I'm involved in mainly atmospheric application examples, so I will just highlight you some examples how Copernicus data can be of help under the atmosphere services component. And so one is wildfires. So probably you heard in last year's wildfires, they get more frequent and they also get more severe. And we also just have, just now happening, one of the severe fires in 2023 in Alberta and Siberia. And so Copernicus provides data that these wildfires can be better monitored from the beginning to better assess the fire risk, but also during the fires to monitor, to better understand also where the smoke and the fires could also migrate to. And so there's just two examples from the Sentinel-3 satellite. There are 2 instruments, and so one is the OLCI instrument, which provides specifically for fire monitoring, level 1 true color images. So we see here clearly over Alberta smoke resulting from fires. So this is on the bottom, and then on the top, on the left, we have Sentinel-3 SLSTR data. So this is another instrument, and this is a level 2 processed product that already gives processed information on fire radiative power. And we see also here over Alberta higher values for fire radiative power. Then there's another application area which is which impacts also many areas are dust storms, and so we have here an image here on the bottom, an image from the Alps, which are colored in brownish red, and this happened in last year, no, 2022 in March, where a strong Saharan dust event was brought up to Europe and colored snow in the Alps brownish red. And so there is also other, and there is actually, this is an example from the Copernicus atmosphere monitoring service. This is the model forecast data for from yesterday, so the forecast from yesterday, from 11th April, and there's in fact a Saharan dust event expected to happen or to come to Europe in the next few days. So this is one example of the data, but also satellite information. So one prominent example for atmospheric monitoring is Sentinel-5P, Tropomi, and here we have an example of another dust event that happened over the Canary Islands on 3rd of April to provide information on ultraviolet index information, aerosol index information. And then the third area is air quality. So this affects us, everyone. So this affects everyone, and this is also getting more and more crucial to better understand the air quality and also to better understand pollutants and emissions and how to mitigate it or to improve air quality. And so this is another example of Sentinel-5P nitrogen dioxide in this case that helps us to better assess the air quality status worldwide. Okay, so there's just an example of how Copernicus data can be used for some application areas. Now I would like to come to bring some numbers here and to better understand where we are going. So so there's different numbers on how much data is generated via Copernicus, but the recent numbers I read is like that there's around 16 terabytes of data produced daily, but then if we, of course, sum it up, it's like petabytes available to be used, and important also freely and openly available. There are six satellite constellations already launched since 2014, and there is many more high priority missions, or there are other 6 high priority missions to be launched by 2027. And this results into an unprecedented amount of satellite, model, and in situ data available, which is good, but this also leads to a diversification of users. So there's a lot of, so it's not only expert users or people coming from the remote sensing or satellite background, it's many different users are interested in using the data and better understand our Earth and the processes that are involved. But if users trying to use the data, there are challenges, or they face challenges. And so I did a study among users of big Earth data some years back, and 231 users participated in this study, and I asked them, okay, what are the biggest challenges you face with large volumes of Earth observation data? And so this is a modified image from one of the papers that came out of this study, showcasing that challenges are related to, or the top 5 challenges users are facing are related to finding the data, accessing the data, interoperating and combining data, and also to not having a good understanding, and also the growing data volume and limited processing capacity. So data is there, but it is really difficult to use. And increasingly as well, and this is what we realize through our activities with training, is that also a challenge is to understand or make users understand, and we call it fitness for purpose, so which means what the data can be used for, but also what are the limitations of different data, because the data can help, but they also can't solve everything. And this brings me now, after a long introduction, to more like the part why we are here at JupyterCon. So the current state is that we have a lot of data, but the potential of the data use is not unleashed, and this is when Jupyter comes in. So how does Jupyter support the uptake and use of Copernicus Earth observation data? So there are 4 different aspects we see how Copernicus benefits, how Jupyter benefits the Copernicus program, and specifically also at EUMETSAT. So it's first training, so to help users finding data, working with the data, handling the data. Then also data access and handling. So there are already data access systems that provide as an interface to access the data, a Jupyter Lab and Jupyter Hub interface, but also we use Jupyter for outreach purposes and also to build a community of Earth observation data users. So the overall goal is to increase the use and uptake of Copernicus Earth observation data, but if we see, and I'm involved in a lot of training activities, and we realize that in this field of Earth observation data education that comes from a data provider, there are some specifics to the training involved. And so this means that we have a challenge often to actually understand our training audience, because it is very diverse. So it is diverse with regards to knowledge about and background about Earth observation data, then experience and knowledge in coding and programming, and also knowing like diversity in thematic application areas and interests. We also use a diverse set of training modalities and they can range from short webinars that are mostly from 1 to 1.5 hours to week-long intensive training schools. But also in the past years, we had already quite a few massive open online courses where then several thousands of users are being informed of Copernicus data, and they usually then also accompanied by with Jupyter notebooks. We also realized that we need a flexibility with all the training materials we create, and this flexibility has to provide us that we can teach the training material in different ways. So the training material has to be ready to be taught online, but also on-site, or if we have in-person trainings. And at the same time, it has to be sufficient for instructor-led trainings, but also it should be able, or users should be able to follow it in a self-paced manner. So when I talk about Jupyter and Copernicus, and I talk not only about Jupyter notebooks, we really leverage a wide set of the Jupyter ecosystem. And I think we can group it into 3 parts, how we leverage the full Jupyter ecosystem. So for hosting and sharing, but mostly for hosting, we use GitLab and GitHub. So we push all our notebooks and material on either GitLab or GitHub. And then we provide an executable version of our trainings via Jupyter Hub, Jupyter Lab, but also it can be shared via Colab, Binder, or Kaggle. And then we also additionally always provide a static version of our trainings via NB Viewer and also a Jupyter Book, or the Jupyter Book interface. So what training is available? I made here an overview, so specifically from EUMETSAT, Wikio, and also ECMWF. So James already also mentioned this. So from EUMETSAT, we developed around 100 notebooks on different application domains, such as atmospheric monitoring or marine. Then from ECMWF, there are around 20 notebooks available for the 2 Copernicus services, CAMS and C3S. And from Wikio, which is a a cloud-based processing system from Copernicus. So this has the benefit and advantage that it already gives you access to Copernicus data, and on top you can get also a processing infrastructure. You have there is around 50 notebooks available, again, from different Copernicus domains, including notebooks on machine learning, because there was just a massive open online course some years ago. So now I will go through some examples how we leverage the full ecosystem. So we have notebooks, what I just showed you, but now we also have, we call them thematic modules on different application areas. So, and here we leverage the Jupyter book in combination with Jupyter Lab and Jupyter Hub. So we have 2 Jupyter books developed on wildfire monitoring and on dust monitoring. And these Jupyter books give a nice entry to users and learners to understand more in depth about what it means to monitor dust with satellite images. And then we have notebooks that showcase different data and also how the data can be leveraged for this specific application domain. But important is, and this is also our principle, so we not only have this Jupyter book, in the back end for each of these Jupyter books is a dedicated Jupyter Hub server. So when you browse through the Jupyter book for each of the notebooks, you will get a button or a link that you can also open a Jupyter Hub in order to execute a notebook. And then you have the same image of notebooks or the same set of notebooks available on this dedicated executable platform. Another example, and this is the result of when we started. Of course, we started at some point with 1 notebook, right? But then we got more collaborators, we got more teams working on notebooks, and then we all of a sudden realized, okay, from the atmosphere domain, we have 50 notebooks, from marine, we have another 30 notebooks, then we had this massive open online course, there is another 30 notebooks, and we had a bit of a challenge to also help learners and users in the end to also guide them better, okay, what material is available. And so the result is, we call it EUMETSAT Train Hub. It is a browsable so it's a website that allows you to browse through all the notebooks that are available from EUMETSAT under different application domains. So this website also gives you a search functionality based on different metadata. So like if you're interested in notebooks from a specific satellite or from a specific parameter or from a specific application domain. So we really try to help users guide through the process to really find as quick as possible also what they're interested in. And so then it gives you a nice overview of all the notebooks available, and then you can also click on each notebook, and then you have a rendered version of the notebook, and in the back end there is again an executable Jupyter Hub instance. And here we leverage Jupyter Lab, Jupyter Hub, and the notebooks are hosted on GitLab. Important here to mention is that at the moment it is on a beta version. So like if you follow the first link, you will get a same outline as the screenshots here. We are just migrating to the operational Train Hub, and in the next month it will also become available on trainhub.eumetsat.int. But for now you will see a different interface if you go to Train Hub, but it is in process. So, and the same idea also was taken over from Wikio, so from this computing cloud platform. So there is also now on top of Wikio like a browsable version of all the notebooks available, and you can also get here or you can have a look to all the notebooks available on Wikio. The only difference here that the notebooks are hosted on GitHub instead of GitLab. So the important aspect with these 2 notebook hubs, we call it, is that we had, because they are, so if we go back, so they're fed with a lot of information of each notebook, right? So we have a title of a notebook, we have an author, we have a description, we have a thumbnail, we have also metadata that describe what the notebook is about. And so we were thinking, okay, so how can we make this in a very easy a way, in a seamless way, that we also don't have another database we have to maintain. And so we came up that like all the metadata that these two the train hubs or these two platforms need, they are stored on each notebook level. So we have information in the metadata. So we developed the entire metadata schema that is also applicable to different application domains. And so it includes title, author, description, thumbnail, hosting services, and also specific tags or metadata that describe the notebook. And with this metadata schema, it allows us to populate all these two websites. Then, as I said, there were already some massive open online courses on how to use Copernicus data. So we had 2 years ago one on artificial intelligence for Earth monitoring. There is currently, or it was launched at the beginning of this year from ECMWF, a MOOC on machine learning and weather and climate. And there was also a Jupyter notebook competition where we asked the Earth observation community to submit notebooks on their application areas, but these notebooks, the competition was that they needed to have a computational narrative to really explain their science behind. So they needed to be nice, not only code and then spaghetti code. So they needed to be nice. And so this was in last summer. If you're interested, there's just another series, a workshop series upcoming on data visualization and storytelling. It starts, in fact, next week. And there we also, each week, we go through different application domains on how you can use Copernicus data for storytelling and data visualization. Okay, then I come to our lessons learned. So I start with our advantages, so our positive lessons learned. So what we learned is that notebooks, because we have a very diverse training audience, as I said, a lot of learners or users, they actually not very skilled or experienced with coding. And so our experience is that notebooks, they remove elements of fear. So it is more familiar to open a notebook and it looks like a website in the end than a command line. And so we had made really good experiences on bringing different users or learners with different coding experiences together in trainings, and even if some didn't have a lot of coding, after the training, they could follow a notebook and also could make some changes. And then a big plus is also the wider ecosystem. So the combination of Jupyter Book, Jupyter Notebook, Jupyter Lab, Jupyter Hub really helps us to have a training material that is seamlessly available for different audiences. But important is also that we have the feeling that that helps to give to allow different people with different learning styles, we cater for them. So we have the feeling if some people just like to browse through a website, we can cater for it. But at the same time, if some people want to jump directly to the code, we can also cater for them. And yeah, as I said, this is probably in general, because I would say to make notebooks useful for different training settings and specifically also for self-paced learning, it is possible, but we have to also add an additional step on making notebooks then also really educational and useful. But in particular, they can be used for training in different settings. Okay, so what doesn't work so well, and I say specifically yet, because there are already a lot of developments what we're sure during this conference, and I think it's just a matter of time. And probably it's not only, it's just in general, we have to make compromises, and I think this will always stay the same. So we have to make a compromise between, okay, what for teaching pre-installed Python environment setup, which we have with a Jupyter Hub. So it is very easy. We can really start with the training itself versus learning also how to set up the environment and also to replicate the training on your local machine. We have always to do a compromise also between making already the data available, because we talk about large volumes of data, and there is a fragmentation of data landscape. So it's not always easy to get the data, and it can take time. And so there's always a compromise needs to be made between already making the data available, between also showing how to download the data. And this is also one of the comments or questions from the previous talk, maintaining notebooks and also all the training content, and the more services you offer, also maintaining Jupyter Hubs, updating Jupyter Notebooks, Jupyter Books. This is a task, and this is also getting more and more relevant and complex, especially if there's also many contributors. Good, so my conclusion, we have a lot of data already, and it grows every day, and there will be even much more data available in the next years. And we also have more services where we can process and access the data. And this means all that, because it's a big paradigm change of everyone involved and interested in the data, and so we already have data training efforts in the Earth observation domain, but we even need more efforts to ensure also the use and uptake of this data. And this brings me back to the Jupyter ecosystem. So it already plays an important and significant role in how users access and process Earth observation data, and this will just be even stronger in the future, because we see already a lot of interfaces, Jupyter Lab and Jupyter Hub or Jupyter Lab interfaces on top of cloud computing infrastructure. So my personal belief is that I think a Jupyter Lab interface will be the access portal how Earth observation data scientists will use and process data in the future. And with this, I'd like to thank you, and I'm happy to take any questions.